Okay, so in this problem we're going to do some conversions of concentration units. Now the units like molarity, molality, mass percents. So how do you convert from one to the other? That's kind of what this problem is about. Okay, so here's the problem. An aqueous solution of ethylene glycol, this is the formula, molecular weight, is used as an engine coolant. It is 40% ethylene glycol by mass. Okay. The density of the solution is 1.05 grams per milliliter. Calculate the molarity, molality, and mole fraction of ethylene glycol. So the molarity of the solution is going to be given by moles over liter, and this, remember, is solution and this is solute. Molality is given by moles of solute divided by kilograms of solvent, not solution. And then the mole fraction is given by moles of the solute over total moles. Okay, so that's kind of where we're going with this. Let's look at our data, okay, and see if we have everything. We know that we have a 40.0% solution, and this is by mass, which means that I have 40 grams of ethylene glycol, and EG is my short form for ethylene glycol, over 100 grams of solution. That's what I have. And I have the density of the solution, which is given to us as 1.05 grams per milliliter. So we have this much. What we don't have is how much solution we are working with. We're never told how much it is. So it's very normal, okay, to assume that you're working with 1 liter of solution then. Okay, so and you can always assume that for any kind of a problem, that if you're not given any volume of the solution, then you can use 1 liter as your solution. So let's go ahead and start with the first problem, okay, which is that we have to calculate the molarity, which is moles of solute over liters of solution. Okay, so the liters of solution. So the liters of solution, first of all, will be calculated from the 1 liter, okay, that we have. The moles of solute, okay, this is the interesting part here, because the moles of solute needs to comes from the mass of solute, and the mass of solute will come from mass of solution, okay, because we have the liters of solution but not the mass of the solution. Okay, so we need to calculate mass of the solution. Okay, and mass of solution is going to be the 1 liter, which is then converted to milliliters, and then you calculate that, you multiply that by the density of the solution, which is 1.05 grams per milliliter. That's the density. So then we have 1050 grams of solution. That's how we know the mass of the solution. Once we know the mass of the solution, then we know that we have 40% mass of ethylene glycol. So then 1050 gram of solution times the 40% of ethylene glycol, and this is grams and grams of solution, and this is going to give us then the mass of ethylene glycol, which is 420 grams of ethylene glycol, and this is going to be then in, of course, the 1 liter of solution. Okay, and then so now we're going to convert to moles. Okay, this one, so 420 grams times, and the molecular weight is given to us, so in 1 mole you have 62.01 grams, which is equal to then 6.77 moles. You can do the calculation, and molarity is moles divided by liters. So the liters of solution is 1, so just divide that by 1, so 6.77 moles divided by 1 liter is equal to then 6.77 molarity. Okay, that's part 1. Once you have part 1 done, then you have a little easier access to the rest of the problem. Okay, because now we're going to deal with molality, and molality is moles of solute over kilograms of solvent. Okay, So this is already calculated now, okay, already calculated, and this is 6.77 moles. All we need to do is calculate for the kilograms of solvent. So this is going to come from the mass of solution that we calculated in part A. So solution was 1050 grams. The mass of the solute was 420 grams of ethylene glycol, which means that we are left with 630 grams of water. Okay, because that's the important part. We have to make sure that we calculate the solvent and not work in solution. So once we have the 630 grams of water, we convert that into kilograms, which is in 1 kilogram there is 1000 grams, then which is 0.630 kilograms. And then to calculate molality is 6.77 moles divided by 0.630 kilogram of solvent, which is then 10.7 molality, okay, of the solution. So then that's the next part. All right, so things are becoming a little easier, I hope. Now for the last part, which is the mole fraction of ethylene glycol. Remember, mole fraction is given by this funky looking X. Okay, so now we need moles of ethylene glycol divided by the total moles, which is moles of ethylene glycol plus moles of water. So we already have the moles of ethylene glycol, okay, that is 6.77 moles. We need to calculate the moles of water, okay, and the moles of water will come from mass of water, and the mass of water is 630 grams. So convert 630 grams of water to moles, which is in 1 mole we have 18 grams of water, so that is equal to 35 moles of water. So then we can calculate the mole fraction of ethylene glycol, and that is 6.77 divided by the addition of 6.77 plus 35, add that together, and that should give us 0.162. Now these ones don't have any units because it's a mole fraction. So if it's a mole fraction, it's the same units divided by the same units. Okay, so this is how you would calculate it. Again, remember, the important thing is that you have to assume it's a 1 liter solution, and the key step, okay, this is the key step, okay, to figure out the mass of the solution. Once you have the mass of the solution, then you can calculate everything else. We'll do one more problem, so you can go on to the next one if you want to.